Good evening. Today I am going to explain you vertical projection from the top of a tower. So, we see different cases here. So, vertical projection from the top of a tower. Look here. We know equations of motion in general as V is equal to U plus AT, S is equal to ut plus half at square, V square minus U square is equal to 2as, Sn is equal to U plus A by 2 into 2n minus 1. All these equations of motion are applicable when the acceleration is uniform. When the acceleration is uniform, all these equations of motion are applicable. Already we learned this. The same thing we are applying here. Let us consider a tower, okay, of height h. From the top of the tower, a body is projected vertically up. It reaches a maximum height and then it comes back to the ground. So, we have considered a tower of height h. A body is projected vertically up with a velocity u from the top of the tower. Okay. So, it reaches the maximum height and then it comes back to the ground. Now, here initial velocity of the body is u. It is in the upward direction. Always acceleration due to gravity acts in the downward direction. As the direction of acceleration is opposite to that of the initial velocity, here A is equal to minus g. At any instant of time, if you are asked to find the velocity, we take the equation V is equal to u minus gt. At any instant of time, if you are asked to find the displacement of the stone, S is equal to ut minus half gt square. If we need to find the displacement of the body in the nth second, then we go for the formula Sn is equal to u minus g by 2 into 2n minus 1. Just in those equations of motion, we have substituted minus g in place of a. So, all these equations are pretty much same as vertical projection from the ground as well. Here one particular model is very important and common in the objective examinations. On reaching the ground, a body projected from the top of the tower, it reaches the ground finally. On reaching the ground, what is the displacement of the body? See here, you have projected the body from this point, it travels all the way along that path and finally it reaches the ground. So, the displacement of the body is the distance between the initial and final positions. It is nothing but the height of the tower. But initial velocity is taken as positive, any other direction opposite to initial velocity will be taken as negative. So, here displacement as it is in the downward direction opposite to that of initial velocity, it is negative, that is S is equal to minus h. If time taken is to reach the ground is t, then if you substitute this in this expression, it becomes minus h is equal to ut minus half gt square. This is a very common equation. If a body is projected vertically up from the top of the tower with a velocity u, if it reaches the ground in time capital T and if h is the height of the tower, then minus h is equal to ut minus half gt square. Okay, just we will do one problem based on this equation. let us consider a tower. So, let us note down the problem. A body is projected vertically up with a velocity 20 meter per second from the top of a tower of height 80 meters. Find the time taken by it to reach the ground. Take the value of g as 10 meter per second square. So, a body is projected vertically up with a velocity 20 meter per second from the top of a tower of height 80 meters. Find the time taken to reach the ground and take the value of g as 10 meter per second square. So, here a body is projected vertically up from the top of a tower of height h with a velocity u, and if it reaches the ground in time t, the equation connecting them is minus h is equal to ut minus half gt square. Just substitute the given data in this equation and you see what happens. See here, minus h is equal to u t minus half g t square. So, minus 80 is equal to 20t minus 5, 2 gets cancelled, 5 times 5t square. So, if you bring this to this side, 5t square minus 20t minus 80 is equal to 0. You can take 5 as the common factor and cancel that. T square minus 4t minus 16 is equal to 0. So, I think there are, so this is a quadratic equation. So, suppose if ax square plus bx plus c is equal to 0 is the quadratic equation in terms of x, then its solution is minus plus or minus b plus or minus root of b square minus 4ac by 2a. Here the time cannot be taken as negative. So, t is equal to minus b, minus of minus plus root of b square 16 plus 4 b square minus 4ac. So, actually minus 4, a is 1, c is minus 16, minus of minus becomes plus, so it becomes 4 into 16. So, divided by 2, a is 1 here. So, what do we get? Look here. So, look here. So, t is equal to 4 plus a root of 16 plus 4 16s are 64. So, it divided by 2, 1 by 2. So, t is equal to 4 plus root 80 divided by 2. So, 4 plus root 80 is 4 root 5 divided by 2. So, answer is 2 plus 2 root 5 seconds. That is the total time taken by the body to reach the ground. Okay. So, when a body is projected vertically up from the top of a tower of height h, if it reaches the ground in time t, then equation connecting them is minus h is equal to ut minus half gt square. Okay, this is one model. Now, let us go to another problem based on the same model. Look here, a body is projected vertically up with a velocity 20 meter per second from the top of a tower of height h if it reaches the ground in 5 seconds. Find the height of the tower. If it reaches the ground in 5 seconds, find the height of the tower. So, a vertically projected body from the top of a tower reaches the ground in 5 seconds, find the height of the tower. So, the formula is minus h is equal to u capital T minus half gt square. So, height of the tower we need to find it out. Initial velocity of projection is given as 20 and time taken to reach the ground is 5 minus half. Actually in the problem let us assume g is given as 10 meter per second square, half g t square is 25. So, it is minus h is equal to 5 20s are 100 minus 125 minus h is equal to minus 25 implies height of the tower is 25 meters. Okay, that is another model. Now, we are going to see another application based on this vertical projection from the top of a tower. So, note down the question very carefully. A balloon is rising vertically up, with uniform acceleration, A is equal to g by 8. After 8 seconds, a stone is released from it. A stone is released or dropped from it. Find 1. Time taken by the stone. To reach the ground. 2. Its velocity on reaching the ground. 3. Distance between the stone and the balloon. 2 seconds later, stone release. So, a balloon is rising vertically up with uniform acceleration g by 8. After 8 seconds, a stone is dropped from it. Find first time taken by it to reach the ground. Time taken by the stone to reach the ground. So, let us do one after the other. In this case, let us try to understand the problem. Let this be the ground. Let this be the balloon. Balloon is rising up with uniform acceleration A. After 8 seconds, this is the location of the balloon. So, at 8 seconds, a stone is dropped from the balloon. So, here at that instant of time, the balloon has some velocity. So, as the stone is released from the balloon, the initial velocity of the stone at the instant of release is same as the velocity of the balloon at that particular instant. This is the most important concept to understand. Look here. Imagine a balloon rising vertically up with uniform acceleration. After some time, a stone is dropped from it. So, if a stone is dropped from a vertically rising balloon, simply it does not fall. It goes up and falls down, exactly similar to the case of vertical projection from the top of a tower. So, at the instant of release of the stone, initial velocity of the stone is exactly equal to the velocity of the balloon at that particular instant of time. So, for the stone, you need to find out the initial velocity, which is same as the velocity of the balloon after 8 seconds. Now, this is exactly similar to the case of vertical projection from the top of a tower. So, the stone moves like this and then it comes back to the ground. Let h be the height reached by the balloon at the instant of stone release. Suppose, and g is already given, so need not, we do not require the value of g anyway here. So, if you know u and h, then you can find out the time taken by it to reach the ground using the relation minus h is equal to ut minus half gt square. So, here the challenge is to find capital T, you must know h, you must know u. So, u is the velocity of the balloon at the instant the stone is released from the balloon. So, here let us consider the balloon. Okay. So, balloon starting from the ground, that is from the point A, it has reached the point B. So, as far as the balloon is concerned, initial velocity is 0, A is equal to g by 8, t is equal to 8 seconds. So, what is the final velocity at time 8 seconds? So, v is equal to u plus at, u is 0, a is g by 8 and t. So, v is equal to, v is numerically equal to g. And then you want to find out the height of the balloon, that is s is equal to h is equal to how much. So, what equation connects them? U, A, T, S is asked. So, s is equal to ut plus half at square, u is 0, half, a is g by 8 into t square is 8 square, 64, 8 times, 4 times. So, h is equal to 4g. Now, look at those two values properly. Okay. Now, for the balloon, for the stone released from the balloon, initial velocity is velocity of the balloon at the instant the stone is released, that is equal to g. As it is released, acceleration of the stone is minus g and height of the tower is equal to 4g. So, you are asked to find out the time taken to reach the ground. We know minus h is equal to ut minus half gt square implies minus 4g is equal to u is gt minus half gt square. Just if you look at it, you can take that g as common factor outside. Minus 4 is equal to 2t minus t square by 2, or minus 8 is equal to 2t minus t square. Now, taking this to the other direction, t square minus 2t, t square minus 2t minus 8 is equal to 0. That is a quadratic equation with the roots as 2, 4. So, this becomes t minus 4 into t plus 2 is equal to 0 implies time taken by the stone to reach the ground is 4 seconds. Isn't it a beautiful question? So, I am explaining you the question once again. Look here, you have to travel with the balloon. A balloon is rising vertically up with uniform acceleration starting from rest from ground with an acceleration g by 8. After 8 seconds, a stone is released from it. Then the first question is, what is the time taken by the stone to reach the ground? As far as the stone is concerned, here when it is at a height h, when the balloon is at a height h, stone is released from it. So, the initial velocity of the stone is same as the velocity of the balloon at that instant of time. So, it is upward direction. So, the case is exactly similar to the case of vertical projection from the top of a tower. So, we can assume that a stone is projected from vertically up with a velocity u from the top of a tower of height h. What is the time taken by it to reach the ground? Just we know this formula, minus h is equal to ut minus half gt square. Leave it there. Here the challenge is to find a t, you should know u and you should know h. Okay? So, here as far as the stone is concerned, initial velocity of the stone is velocity of the balloon after 8 seconds from its start. So, let us consider the journey of the balloon. So, balloon started from rest, u is equal to 0. Moving up with uniform acceleration, a is equal to g by 8. After 8 seconds, a stone is dropped from it. So, you have to find velocity at 8 seconds. So, using relation v is u plus at, you could find velocity. Using the relation height at which the balloon is at the instant the stone is released, we could find, and substituting that value of h and u here, we could get the value of time taken by the stone to reach the ground. Okay? So, if you want to hear it once again, just repeat the video, that is it. Okay? Now, the second part of the question is, you need to find out the velocity of the stone, its velocity on reaching the ground. Okay? So, look here, we want to find out the velocity of the stone on reaching the ground. So, as far as the stone is concerned, look here, initial velocity of the stone, u is equal to, just now we found the velocity of the stone, it is equal to g. Acceleration of the stone is minus g. Time taken by it to reach the ground, we could get it as 4 seconds. So, velocity of the initial velocity of the stone is g in the upward direction, and it's as it is released from the balloon, its acceleration is g. So, t is equal to 4 seconds. What is the velocity of the stone? So, actually this is the stone, it has moved up and then it has reached ground, its initial velocity is g. Okay, u is equal to g, and acceleration due to gravity is in the downward direction. So, what equation connects them? Yes, v is equal to u plus at. So, v is equal to g minus g into t is 4 seconds. So, v is equal to minus 3g. Okay. If we take g as 9.8, it becomes minus 3 into 9.8 minus 29.4 meter per second. We do not have any problem with the value, but why we got a negative sign there for velocity? It is just simple. Here you have projected the body up, but finally the body reached the ground in the downward direction. Final velocity direction is downwards, whereas initial direction is upwards. That is why we got a negative sign. That is the second part of the question. And in the third part, you are asked to find out the distance between, third question asked is distance between the stone and the balloon. Stone and the balloon, 2 seconds later the release of the stone. So, follow me very carefully. See, this balloon actually is raising vertically up with uniform acceleration. At the instant of release, let its velocity be u. and the stone, it moves up and then it falls to the ground. As far as balloon is concerned, displacement S1 is equal to ut plus half at square. As far as stone is concerned, displacement is ut minus half gt square. Distance between the stone and the balloon is S1 minus S2. This is equation 1, this is equation 2. From these two equations, S1 minus S2, ut gets cancelled. It is half t square, if you take it as common factor, a plus g. So, distance between the stone and the balloon, in this case, t seconds later the release of the stone is, suppose if you call it as delta s, this is half into, just rewriting, g plus a into t square. So, half g plus a acceleration of the balloon, g by 8, and t square is given as 2 square. So, half 9g by 8 into 4. So, it is 9 by 4 into g is 9.8. How much is that? 2.45, isn't it? So, here 9.8 by 4 is 2.45, 2.45 into 9. It is around 22.95 meters. That is the distance between the stone and the balloon. So, is this problem clear? Okay. So, all the three models are covered in the single problem. A balloon is rising vertically up with some acceleration, a stone is dropped from it. We found the time taken by the stone to reach the ground, velocity on reaching the ground, distance between the stone and the balloon, t seconds later the release of the stone. Okay, I will stop here for today. I will continue with another topic tomorrow. Thank you.